Okay, now you can also share your camera.
Okay.
Okay, and then once you are ready, just share the screen, and that's it. Awesome. Thank you.
Test. Test.
So when the tech
Okay. Yeah.
figures out, and
Sure.
at the point when this starts working, I'll start passing it.
Thank you. So he has a link, but doesn't work with him.
Oh, it turns out that the mic is working, or the tech start back, he will kind of try to figure it out, and when he does, I'll start passing it.
Okay, great. Okay. Okay.
We have 2 minutes.
Yeah. Look, anyway, if questions come up, we come up later. So
Yeah.
it's like more, less of a question, more of a comment, really. Yesterday, I was so confused with the yield error message. I was like, what? Why? How? I was really like questioning whether I know how to program OCaml. Oh, well, it's just using the type annotations, right? I was like, what? How can this? I do not understand. I was just like, the type error is just so bad. I think there will be something to fix, because the type error is just.
Yeah, so there is no fit here to, so if you don't handle the effect, you see an unhandled exception.
Mhm.
I think we
Yeah,
saw when we are playing
that
around.
makes sort
No,
of.
but there is nothing here to tell you which exception is unhandled, which effect is unhandled.
Ah, okay. It doesn't tell you.
It doesn't tell you right
Oh,
now.
that's yeah.
Yeah, but the PR is not getting merged, so we don't know if it will be in 5.0.
Who
Yes,
submitted it?
he's PR this.
Okay.
I don't know what the contention is.
Okay. Huh. That would be a useful addition.
Yeah, it's very useful. The effects are also not checked.
Yeah. It's like
I mean,
exceptions,
that's
so
only like,
that's just like it. So it's,
yeah.
but I'm kind of feeling it would be fun, because people in Lua are saying like, oh, we have coroutines and we can do like so many cool things with coroutines. I'm like, I kind of wonder whether we can, how it compares to effects, and I kind of feel like exploring it, just to
So we
see.
do have that web solution.
Yeah.
We have a version of HTTP.
Yeah.
We have a restricted.
Yeah, we should fix this.
Yeah, and it's also go. I don't know if it's a go server. We run benchmarks to compare.
No, but also just mostly just like what can you do, like what can you build? Because it's basically configurations, like one-shot information. This is just like way more powerful than just exceptions. So you can build exceptions out of it, which like we don't need to, because we already have those. But you can build other things. I'm kind of curious what other things you can build with this.
So the project, one of the students, so we tried to use Java.
Oh, okay. Ah, yeah. Yeah. I'm just thinking whether you can use it like to structure your thread or something like for like backtracking or something where people use.
Yes,
Yeah. Like
because it gives you better practice.
yeah. Yeah. There's tons of interesting things.
And if you're interested, you can start working with
We should definitely fix the one from Arthur. He wrote this. I can send you the link. It was in the EIO thing. We should update that and make this a post or drop in some makers post because it's actually great. Like it's like if you read it, it's oh okay, this makes us it's nice. It's a good introduction actually. Somebody actually mentioned like, oh that's really nice post. Like, yeah.
We should update
Yeah, we should update it and maybe read it. But of course, asking first whether we can reuse it. But I don't think he was.
All right, hello again. So I think we are just about time to start with the next session. If there's anyone who is not in the first session but join now, you can access the slides from the event in the ICFP website. And also you have the installation instructions for installing OCaml 5 and the libraries we have used in both the repository as well as on the slides. So you could start with installing it. So we just have a few bits left in parallel programming. We'll get done with that first and then we'll move to FX. So to continue, we are so we'll resume with domain local storage. So I think we briefly saw what domain local storage is during the domain API. But so domain local storage is basically like global variables that are specific to domains. I think it will be useful to see this example to understand how exactly they could be useful. So this, what we do here is we have an empty array, similar to the initialization example that we saw earlier, and we are just populating the empty array with random numbers. So one interesting thing that was in the OCaml standard library was that the random module in the OCaml standard library, which is what we're using here, used to have global state. So what that means is if you try to use random from multiple domains at a time, that's going to cause contention, and that is going to uh, stop your program from scaling. So, what we did here is you have a separate random state for every domain, and you just use the random state of your particular domain to generate random numbers and then populate your array. So, that is basically it. The way it works is if you want to create a new domain local storage variable, you just create a new key uh, with an initializer. So the initializer takes a unit and returns whatever it is that you want to initialize it with. So let's say if you want to initialize this new key with 42, it's just going to be lambda of unit to 42. So whenever you try to get this value, which is here, domain DLS get, uh, so it's going to return what is in the initializer. You can also update it in the context of the domain with the set function with whatever new variable that needs to be there. So, but word of caution, it's not recommended to use domain local storage until it's absolutely necessary because they're as bad as global variables. So, and so the other bit is synchronization. Let's look at this example. So what we do here, we have a variable v which is reference, and we just increment this reference some n number of times, and this is going to we are just printing the result in the end. Let's try to run this. File is counter mutable. Let's say I'm running it. So so this is straightforward. Let's say we want to do this increment in parallel from different domains. This is how you increment it. But there is a problem here. Does anyone want to guess what the problem is? We have a reference variable. All this increment function does is it increments the reference variable by n number of times. And we are calling this increment function from 4 new domains as well as the parent domains. So essentially, we are calling this increment 5 times from parallel domains. So what happens here is we have the domains as well as this increment running in parallel, and all of them end up accessing this reference variable v. This reference variable v is not thread safe, meaning it's not uh, sure that what value it is you're going to read. Let's say you have two threads, two domains, domain 0 and domain 1, both trying to increment v. How this happens is domain 0 first tries to read v, it then has to increment v, and then it has to write it back to v saying this is the incremented value of v. And the same process is repeated by domain 2. So when these two are running one after the other, there's no problem. But when the two of them are running at a time, you don't know the interleaving in which this is going to happen. So that would end up with some non-deterministic value for v, which we can see in this. So let's build this. All right. So this is actually supposed to give us 5 times 10 to the power of 6 because my n was 10 to the power of 6. But if you see it returns some other value here, and the value is not the same every time you execute it. That is because every time you execute it, it takes a different interleaving of reading v and writing v from the different domains. So essentially what happens is you get some incorrect output, which is also non-deterministic. So that is not great. To make this right, we have to make the updates thread safe. So there are two ways to do it. One of them is to just put locks around your updates, which is what this one does. You just create a mutex. You this increment is where I'm sorry. Yeah, so this increment is where the actual work happens, and this is where it could go wrong if it's not thread safe. So if we just lock it with a mutex, what it means is the mutex is going to wait until uh, the execution is actually done and then release the lock. So when the lock is on, other domains will not be able to proceed with the same operation. So let's try to execute this. Let's try with a bigger input. Yeah. So this gives us the correct answer. Yes.
In the example of the construction of it's quite special. Like it's not just 10,000 use time hash block around it and return 10,000. So I'm just going to. So why do you need this? This is kind of like provide compiler to optimize it.
Sorry, can you repeat the question? I lost the first part.
Like if you check the example code.
The previous one?
Yeah.
This one?
It is. It is. No, it's not. It's like trying. It's missing a little bit. Oh, I see. Then he just explained.
Okay. Okay. Cool. So this is one way of making this thread safe. And also it is worth to note that the abstraction for mutex is same for the different abstractions that we have for expressing concurrency and parallelism in OCaml 5, which are domains, fibers, and systhreads. So we could just use the same mutex interchangeably between domains, fibers, and systhreads. So by systhreads, I mean it's the thread module in the standard library. Since there are lots of threads, we just use the term systhread to distinguish it. Any questions on this before we proceed? All right. So the other way to make this thread safe is to use atomic variables. So OCaml 5 ships with the C11 atomics that lets you create and use atomic variables. So all you have to do is we had a ref here. Just change this ref to an atomic variable. And we do the same thing. So internally, how this works is atomics use hardware operation called compare and set, and that makes sure that your operations are thread safe. This is we hope this is something people have to use rarely, but it's still something that would be useful in some cases, I guess. Yes.
Why is it not by default atomic? Like incrementing, why is it not by default atomic?
So we use a reference variable here, right? Reference is not thread safe by design. Reference is just a mutable variable. So if you try to mutate it from different domains, it's not going to be thread safe.
Okay. But why? So is this the increment here is not atomic?
It's not atomic, yeah.
So before it was not a problem that it was not atomic because that it could never be descheduled because there was only one thread running. So before there was no securities about this, so it didn't have to be atomic.
Okay.
Yeah, this doesn't have to be atomic if you're just running it on one domain. It is a problem only when if you're trying to write it to the same ref from different domains. Even if you have just say one thread that's writing updates and you're reading from multiple threads, that's still thread safe. It's not thread safe only when you're updating it from multiple domains, which is exactly what they're doing in this one.
Is there some sort of performance penalty for using atomic?
Yeah.
Okay.
Yeah. So typically atomics are faster than locks, but they're still so slower than reference variables as expected. Usually they are faster than locks, but it depends on case to case basis. You cannot generalize that. Yeah.
So in a synchronous task, I mean, in a synchronous program,
Yeah.
if a programmer uses atomic operations instead of web,
Yeah.
it will be slower.
Yes. But the thing we are looking for is correctness. So we could actually try to. So we have the log question as well as the atomic question. We could maybe try to see. So this runs okay. If you see this, the log question is somewhere 4 times slower than the atomic question. But it also depends on the number of updates you perform and how often you do it.
You said it's an operation on the processor.
Yeah, compare and set is a hardware operation.
And is there a limitation on like how old the hardware is? Or,
Limitation on?
like, is this operation on only new hardware or it is?
I think it's supported by almost all hardware. It's, I mean, it's not something implemented in OCaml. It's just imported from C11. OCaml runtime is essentially written in C. So we just use the C11 atomics and provide abstractions for it from OCaml. So it's not something we have re-implemented from scratch. Yeah, so with this, we are done with the parallel programming section. There is, however, an exercise in Queens which I would recommend you folks to do it at your own time. So the next part of it is the concurrency bit. So concurrency is in OCaml 5 is essentially expressed through effect handlers. I believe some of you might have been at Casey's keynote yesterday, where he talked a bit about how they were implemented. So we'll see how they are used to express concurrency with OCaml 5. So effect handlers are essentially one-shot continuations. Um, think of it as exceptions. Only thing is you can resume the exception. With exception, you would essentially stop the program when you encounter an exception, but with effect handlers you can actually continue the program even when you encounter something that stops you. We will see with some examples. So this is a very simple example. uh, all we do here is we are printing 0, and then you perform effect e. We'll see what this effect e is, and then you print another string 3. So this, okay, I think it's better if I switch to the code. This is the effect. This effect is going to return as a string. That's what this means. And it is expressed as an extensible variant type, which is why we have this expression here. We could have multiple effects expressed in the same extensible type. This function print, all it does is it prints 0, then it performs this effect E, and after that it again prints another string 3. So when the control goes to this perform, it looks for a handler for this particular effect, which is what we have here. So this particular bit is the handler. So there are three possibilities here. Red C means that all is well, you have something returned, so you're just returning the result. EXNC means that your perform has returned an exception, and what we do here is we just raise the exception. We could also do something else here, but in this case, we just raise the exception that is returned by the perform. This is the interesting bit. So this FC is when you see an effect returned by the perform here. What happens is the only effect we have here is E. So we match it with E and we say print, it comes with a continuation K. So this is the continuation. We use this to resume the computation for the next step. So we are printing a string here and say continue K2. So, so if you remember, this effect was supposed to return a string, and that's exactly what we are returning here with the continuation. So what this essentially does is this returns 2 to this perform E. So you are going to continue the program with print string of 2. And then it goes here, and then it finally goes to the rest of the handler and prints end line. So if you run this, so if you see it, it prints in the exact same order. It goes to 0 first, it encounters an effect, goes to the handler, it prints 1, then it resumes after you call the continue, which gives back the control to this perform. Then it continues to print 3, then it in the end prints 4. Yes. Type of? On line 6. This is just unit. I don't have Merlin turned on my this switch. So you could try to run it on YouTube to see, or if you have Merlin turned on your system, if you just hover over here, it will show you the type.
And can this match with catch like OCaml exceptions?
Yeah, that's exactly what you do here. So it can catch 3 things. So this is the return value. This is when you have exception raised by the perform. Let's say this perform is raising something like end of file.
Can you do the catch and FC?
Yeah. You can have a say something like fun exn match exn with whatever you want to match it.
You can define new effects in using this.
Yeah.
The exception effect of OCaml is not using this. It's not the type effect.
So what you mean is, can we perform effect with existing exceptions? Is that your question? No, what is your question?
Can you add in line 16?
Yeah.
Like, can you add a new case and to catch the exception?
Right. Got it. So your question is, can we add another field here which catches an exception?
Yeah, before the exception from.
Got it. No, that's unfortunately not possible with this syntax. So previously we used to have fx itself in multicore OCaml, but it was decided not to upstream that. So fx are in effect expressed as functions. So you have the separation between exceptions and fx. But with the real fx syntax, they're treated as one and the same. So you could just match them with, match the exceptions and fx with the same match statement. You don't even need this match with you can just use normal match to match both exceptions and effects. But however, typed effects are in the works. So hopefully they'll be in OCaml 5.1 or subsequent releases of OCaml 5. That's the end goal. Yes.
If we have multiple domains and
Yeah.
one domain performs an effect, does the continuation have to be performed by the same domain?
Yes. So fibers are so fiber is the abstraction expressed in the runtime for effects. So they have their own stacks, which is what makes it easier to use them for concurrency. So they are fibers are tied to the domain they are created in. So okay, so this was a basic example. We could look at a slightly more interesting example, which is the sum effect. So you have this effect increment. It just returns an integer. Let's say we have a function add that calls perform increment twice. And yeah, this is the handler. So this we have a reference variable here which starts with 0, and when you call this perform, it's going to go to the control of it is going to go to the handler, and it's going to increment this, and then it's again going to increment it and return the continuation. So if we run this, this returns 3 because we are calling it twice. Any questions till now?
Can you show how again?
Sorry?
Can you show how? Can you pass any arguments to increment?
For this one, you cannot, but you could define something like, say, sorry. You could have something like, say, integer to integer effect, and take some argument here as an input, say 6. Okay, so I think it's not in the slides, but we have an exercise for effects, which is this one. This is we have the template file. All you have to do is try to express exceptions with effects. So I would encourage everyone to try this out. And you have the expected output here. And something to note here is pay attention to the types of the function that might give you hints on what could be the way to solve them.
Receive my own exception. Yeah. So this is something that
And then the end will return a value of whatever it says in the so if you have this so in your position, you want to make it say, okay, is a value and you can just continue to use this. Yeah, so, just understand the matching once again. If you know simply what's like it, various reasons. But the basic difference is so that's basically in the title you see the this would be a yes.
Yeah, but
capture.
And is the effect
no, it should be A.
just
So because this Montgomery or implicit like so let's see. So it's just like
yes,
okay,
that's
and primary.
so when they do
Match.
return it will already with the results. And then there's that's why here we do like we just match C and argument.
So yeah,
Right.
And the argument so it calls the function itself, and then the result is put to that side and the right side. And that is whatever that returns is.
oh, when it has to return oh, then so it's like writing. Oh, it's done. Nice. It's just with something like that. At least that's has a condition. It's the big
Yeah, this is what I can type in. That's define this. Effects. You can define this as a.
so what we use this point. Let's need to to use this function. So I
Yeah, so basically you can find it will take the function and if it doesn't have any
so
effects
yeah,
or rates,
so in the definition, we'll just
take
none, right?
the and then return oh no, that was the result.
Any extensions?
No, it's levels. Then that's the effects of the
Okay, so I don't have the magic.
So we're using this as well.
Yes, this is what we so much. We have seen and have nothing like that. So
Unbound value of what?
nothing have value.
What is that? Effect undo.
It's okay.
Oh, it's what is in the yeah, but it's a warning.
So this
Yeah. If you have that, it's the same thing, just something else. The function will return.
I think this exception value argument is specific to
Yes, but here we use if you look at that, basically it's a function. Like
It's with
if you have functions from A to B level, like if you have like this function may return an error. That matter, maybe it's F returns the result.
this works in
No, I guess we can write this.
I mean, this
And like this is math and back. Yes. Well, maybe the like in thinking call. Maybe
yeah,
but
right.
I didn't allow this. So that's all.
That question is going to compose effects.
I didn't allow it.
Oh, yeah.
Right.
And the only
So then you have just follow. It's just and then beside that, and you have
Where to jump back, basically.
Okay, if you never form like that. Oh, so it's actually
that's
so
because
this is just action.
it takes because of us. Instead of
So no, I know. Oh, so you would add your free here, right?
no,
But we still have to.
yes, no, that's really
No, I mean, like we have a cover effect.
have to do it this way.
Oh, so this is extending the effect. Right.
It's just to remove it already.
Right. So basically, I will compile my components to OCaml, I will add the operations here and on my but then the context can also match them. I don't know how it works if you match
No.
maybe for instance what you were starting.
Wait a second. And what do you want to do?
Yes.
So, are we, is the idea that, so currently it defines invalid argument as an exception set? Right. Is the idea that we should be changing that line to define it as
Yeah.
an exception set or?
Just, that's, the exception type just stays as an exception type. It's basically just the argument for the effect.
Okay.
Okay, you just pass the.
Yeah.
And like, so like, is the idea that we would define a new vocabulary?
Yeah.
Like this, so these both remain in scope.
This would be a new effect. Like, exception for the full node. And if you take an exception and always the example, because all the exceptions are at the same time, so you can just say like, oh, it takes an argument of the example.
Sure, yeah, I
That's what.
so right, so now we still have this exception.
Because now you find an effect that returns something.
Right, so we need to like that function called an effect, which gives an exception to the effect handler, and then breaks the example.
Exactly.
Yeah. And like at some point we are actually going to break the real which is what's good for this called the
Yeah. Exactly.
Oh, we can't.
Actually, I don't know if you do this exercise, when I figured it out, I was like, wow, yeah, that's interesting because
I don't know why.
Right.
So it's higher generalization.
Sorry, what's the namespace?
Sorry?
What's the name?
Effect deep. Effect dot deep. Sorry, I think it's just effect dot continue. Can you try effect dot deep dot continue? Let me check.
Oh, right.
So this is so basically this is just to figure that function. Yes, so what this does. There's another very significant. So as an exception, for example, like exceptions are also where you can have one exception. Another exception that you can add your own. And it's just growing this type. Now this does the same thing. It's more equal to down there. So now you use an atlas. Yes.
Which okay, yes. So it's been cast. How do you use just to be able to
It doesn't really cast it. This is just basically this is basically just a simulation that the function effects will be lost if the
Yes.
So this is writing
But this is a good idea of how. Like it's just for exploration. What our They're trying
So, yeah. I mean, this is the effect of then give it like and yes, but yes, no, that's yes, but this is the way you write it. It's not effective. And very short thing. Why is it basically all consistent turns into like this effect. But this one doesn't take it. Like you could have but this one can make this and then you like what's the relationship between the Pascal
there's no age.
and
Yeah, just a quick PSA. If anyone wants to refer to the documentation, it's this one.
the argument ends up. So if you want to say, oh, this is the signature, so you so you so it returns some form given this and then say, oh, if you're not don't care about anybody to defend something, so you only care about so this way. So you in this case you just return it, and that's what you say, like you don't handle it, and then you fail. Yes, that's right. You fail exactly. And again, it's basically return function that will all right. Oh, cool. Yeah, exactly. So what you want in functions, no, it's KAS printf, where you can give a function its all not printed in the library. And that's sort of the same idea that you have like information.
Because
so what we do is
like how do we
we continue. The reference is also one.
that we got some values, and then it means that this value is 1. Then we got the execution of the song, and then this is something else basically. You can still do that. And then we just but because it's an individual and then we add yeah, exactly. And then exactly. And then so we know that there's no more because the function returns is also it's a unit to integer function, and then we'll call this where you when we reach it, we just put that exit, and then at this point the measure is done, and then so here there's nothing else, and we're done.
When X when weights
Okay, so if you were to raise and this is because I don't have the it's only this is so if basically puts an exception around it, and if it's an exception race, then it will this. And you can calculate instead of for basically race, then the J suite still they have several different
I'm a little confused about how to approach this.
No, you cannot. Yeah, you can statement here, right? And then you could
I don't know how to use the.
of course you could say the increment and then just make this number, right? And then yes, you can also pass it if you use it
okay.
if you use it basically, they go down. Functions from module to module. That's it. Because once you figure it out, it's just 30 magic. They're mathematical wonders. So that's it. It's just why is it
That's tight.
actually
It's not about it.
That's how you define an effect. It's an extensible variant type.
But it can also be used as a
Function argument.
as a value to the function.
Why would you do that?
We can pass something to the effect of perform.
Right. So this can take an argument.
It's an A effect of T. I really know how to make that.
So you're
It's like when you find this incrementals like this, it's just that it's an extensible type, so you can add multiple circuits that here.
Okay.
And so increment is not a type, it's just a
okay.
it's a constructor. We have to use that.
Okay, so in the interest of time, I think we can look at the solution quickly. Oh, I'm sorry.
You create a constructor. before. No, because this is if this is a good match. Like if like this is like if all of them. If this somehow has a match. This is an exception.
Yeah.
Well,
It is really this one. If this matches, this is
Yeah, I mean, this is
I think if the back fails, like you could do
That's an factor.
and like if you do
So what are the steps?
yeah, and I know I missed
raise it down,
I haven't used it very soon. I mean, like, so,
Yeah, the unity effect.
Yeah.
Oh, because there's a
I was looking one of these exceptions.
I mean, you would, right?
Yeah.
I guess. Still around.
They add the system effects, and they really because
I have to make sure.
that's exceptions. For instance, you use
Do you have any questions? No? Okay.
I think the same thing. That's what you want. Use the record. You don't use
Okay, I think we are probably running out of time. So, moving on. So the next example, which is a bit more interesting, is this echo server. All this echo server does is it returns whatever value you give as input. This is a Unix-based version. Unix is the standard library Unix module of OCaml. This is a Unix-based version of the echo server. Let's see what it does. Okay. So we have the server on. Let's try to connect to this. So this is one client connected to the Unix server. I am just saying hi. It says hi. Let's connect another client to this. this one doesn't return anything because the server over here is still blocked on this client which we connected to earlier. So what happens is if you kill this client, you get an output here. So this is not nice because essentially you can only connect to one client at a time and it can process requests from only one client at a time. Uh, we could solve this with some existing libraries like say LWT or async that already exist for before OCaml 5. But let's see how that's done with FX. So, okay. These are the interesting bits in the async echo server, the source files of which are also in the same repository. Okay. So we define this as fx, and fork is going to run it in a new context of execution. Yield is supposed to give up the context of execution, but we don't use yield anywhere in this scheduler, just FYI. So if you look at this scheduler, it's going to check for any waiting items in the queue, which is actually populated by the fx over here. I don't think we possibly may not have the time to go through the entire code, but the takeaway here is we stop execution on one context and resume on the other. So that makes it possible to run it on. That makes it possible to serve requests concurrently from multiple clients. Let us just try to do that. We have the server running. This is one client. This is another one. Oh, what we have managed to do here is to uh, stop the execution on one, take requests from the other, and just do them concurrently. So this is the FX bit. We have a new library for tracing. I would suggest trying this out on your machine, but if not, we also have a file over here you can just use as it is. Yeah, so it is this echo async the trace file. So to get the tracing, this is the command. You can just do this shows the latency profile. This is a very small program, so we don't have any interesting numbers here. But for GC intensive programs, this is quite useful to see the latency of the different items we have. And usually it also helps to sort of optimize the bits which have a lot more latency than the rest of the program. Yeah, and this has a nice user interface called Perfetto to just view the file. I would encourage all of you to try it out. So that was the inbuilt effects system. We have a library on top of it called EIO. So, as I said earlier, we already have libraries that deal with concurrency for OCaml before OCaml 5. Which are LWT and async. And there's lots of applications written in OCaml that use LWT and async. So the idea now is to use the effect-based concurrency systems, and it is meant to be a replacement or to succeed LWT and async. Uh, we do have an example that shows you how it I mean, in my opinion, how it makes it nicer to write concurrent code. So this is an example of an LWT program where you open a file, you write something to the file. So with LWT, we are forced to use this monadic model where you just bind on subsequent operations. But if you see the EIO version, it's relatively simpler, where you can do this in direct style, and you don't have to wait for the previous one to be done. Or so this is an example the of how you could use EIO to do something that you already do with LWT or write concurrent code. What's happening here is you just create a new file, you just open a new file and you save something onto the same file. You could there's also an inbuilt tracing system within EIO, so that lets you output easily. Okay, so we have another exercise to play around with EIO. So template is here. This is again similar to the echo server we had here. Only difference is we use EIO. Uh, we have the documentation of EIO published. Yeah. So we have the documentation of EIO if you would like to refer. So this is the bit that needs attention.
What is flow?
Sorry?
So all of these. Yeah, so all of this is the effect, and then this one is like the
Yeah, exactly. So the way blindness works, that's that works to use detect from detect is perform this thing, and then like schedule from other functions while you double is just waiting. So it's kind of like the binding on the concurrency mode, but now there's perform and that's not just
Not to be
while you're just waiting on the perform.
oh, so is this still the sequence?
Yeah, that's the thing.
But like after this is it goes on in the background.
Yeah, so yeah, exactly. So yeah, all this stuff that you need to do this stuff way.
So
It's very synchronous and it's not like you first class.
so if I want this to not be synchronous. No, so this run makes that go asynchronous. It's like noise.
Yeah. That's what the run is represented around it. The run is basically just holding the schedule or running whatever the function it has to perform. Yeah,
If you need that.
Yeah, and there's also like domain, there's different implementation events or there's different schedules or the UV and IO can bring on it, and there will be like another for Windows. So the schedulers can actually be also used like regular select if you want.
So these are
No, I just, am using.
This is very good.
Yeah, this is very.
So like no time there's a run.
And the other aspect is there is we can have your events.
Yeah.
This is basically just a
This is what the job is.
What's the asynchronous here?
It also works
Well, it's basically like
works with.
Yeah.
And that look is synchronous for
That's not
stupid. That's you can't see from this picture might be actually asynchronous under the like presentation. But you don't need to care about what's you don't need to care about what's synchronous or what's asynchronous because you don't do like before you see that shit like whenever you do like something blocking there just completely block the whole thing. There's now now you can just use these functions all these functions from here.
That was like from Tracy.
And you don't have to worry
I was wondering.
Oh yeah. He was like by default like it'll automatically like hit something and it's in there and then all you have to do is like do
An example with the
receive it.
an example with
there's only one magic twist that we can
I mean, you can look at the.
They use this curve to show you something to do with profit. So magic twist works with this.
Oh, okay.
You're looking to look into the. So you can see the grades, example is
Maybe it's worth trying with
it's signatures and be non-blocking.
It's for
Like where before the semicolon could not was supposed to mean like throwing donuts all over your book. Which was a big issue where you have like other versions,
Just the non-OCaml.
facing versions of things. And then you can mix any of it. I will use this all.
What is this?
But Tracy wasn't.
No, I will use this. This looks really nice. I will use this. This is
Okay,
I don't know of anything better.
Oh, it's the first argument, right?
Yeah, it's for you.
Oh, that's one.
Yeah, exactly. That was the same thing.
Yes. Yeah, that's basically like
Let's see.
What is it actually like in terms of?
general,
Okay.
like for any type of way.
It's fine.
The factors of A, T.
And then this continuation signature.
Yeah, that's
Also kind of difficult to.
yeah. So this is the not being returned, and this is not.
Yeah,
But
it's really
that's
nice.
basically the continuation business. Maybe the other type and it's mostly extensible, but I should be able to once. You need to use that. So yeah, it's basically quite yeah, I mean, you can, this is basically just saying that this is like this can be any type, so like the trigger can have.
Well, yeah. But like the thing I was using was,
But I guess the thing is.
fairly common.
No, we're using A because that's the fact that you're going to say, in this example, we're not using A. Because you can ignore the but in other cases, return is only how you specify with the A that you return is like the A from the here.
Yeah, no, it's. It's generic as well.
As well, right?
You can have it separate instead of.
Yeah, but
Because it's not just
because
some you can use like which have to be in the open too, right? Whether it's
yeah, sure.
I do
Okay.
You'll see. You can't see.
Yeah, because that's good. So what
No, but like,
you
yeah,
ignore all the others and they don't care.
Yeah.
That's the whole
Yeah,
world
it's-
and your betterment.
If you're, you can look up and.
You know what, like, I think it's, and it's a
Yeah.
Nothing is just signature.
It's an actual validation.
What happens
Here.
Yeah.
So you're like, that's what, that's what, it's okay. I mean, I accept that there's a difference.
Like,
I just don't understand.
We want to try and get this.
This is, yeah, the problem is that
Switching
from
switch from
some this has no conscious like themselves or the communities.
Oh, yeah, sure.
What do you need then?
My own is just
Because it does that, but it turns me in fact. No, because we can also jump from that. So anyway, without we can't use so much time being analyzer did not change.
What's going on?
It might cause
Okay, we have
If you know they're mutable,
yeah, it was framework to deal with IO. And so all these factors that it needs to
But your example
Yes. And then you want to do remove the initially we had it may or may not.
so what does for you, like in an example, is it performs so you could like in the like whenever you find these schedules program and does something and in the first pattern, whatever you program in the schedule, like the back is just like schedules your program and then you define the things that is being in a way
So you could use.
and also side effect way I use that also has like schedulers for different platforms. So you can have like a regular
So you just can
like the UV scheduler, IOU ring scheduler, and there's
Yeah, you just
you can use like
This is how we did it. I go
performance way.
I'm sure, but that's what I do now.
Then we map it. It doesn't change anything.
Oh, great.
And even we can map it. Oh, what happens if we bind it with funded ID? We like that's a
Yeah, I can write these
questions.
somebody did.
taking us to like, you know,
Well, unfortunately, when it actually does, it's always but after that point,
It makes them the rest of the CI.
Is it good?
Yeah, so you can join your bank, you can do bank job. So that
Yes.
real close
Because we can write it like that.
No, well, if you find problems, you know the like. I thought I didn't get into that. We just keep many people.
Yeah.
But it's not like.
I mean, like we can add it.
Yeah, you can add for any some people don't have time. Some like
I admire
aspect of
All right, so we are almost out of time. So before we leave, I would just like to say some things that might be helpful for people to port their applications to OCaml 5. So the first thing is you can still continue using your OCaml 4 applications on OCaml 5. So we expect that anything that works with OCaml 4 would just continue working with OCaml 5 out of the box. There's been lots of engineering work that went to it to make sure that most packages work with OCaml 5. But we do, if you have anything that doesn't work, let us know. We'll try to fix it. I think there are already some applications that use multi-process programming with Unix fork, and that could be replaced with Domainslib, which is a lot nicer. But the catch here is Unix fork does not have shared state, so that is something to keep in mind. We could also use the library EIO, which does effects in background, effect-based concurrency in background for us, and replace LWT or async with EIO. We have certain bridges to make it easier for people to do that. So we have this EIO LWT library that lets you run EIO code and LWT code together in one single application. We also have a bridge between EIO and async that lets you run EIO and async together in one application. And a very cool effect of this is that you could use these and run EIO, LWT, and async together in one single application. So another bit to note is EIO has multiple backends. So it has an IO ring backend, which lets you use the Linux IO ring for input output. And we have observed that it has given performance improvements to the degree of say 10% by just replacing the backend to start using IO ring. You can use it in any Linux kernel greater than 5.11, I believe. There are also other backends. So there's a libUI backend that would work on Mac, Windows, and Linux. And there's also this IOCP backend that's being developed. We're also exploring the possibility of having a common POSIX-based backend that works for all the three major operating systems. So so I think we have reached the end of it. So I would encourage everyone to start using OCaml 5 and don't hesitate to contact us if you have any questions or any suggestions. We would always welcome any contributions. If you have any libraries that you have ported to EIO or to multicore, we would love to advertise that. So please get in touch. Once again, thanks everyone for joining. Thank you. We would also be happy to take questions offline if anyone wants to.